Hello students, welcome to online class. How are you doing? This is Ms. Adana Ogu, and in today's class we'll be looking at a topic for SS1. So far so good. We've treated topics for week 1 up to week 8. So in this class we'll be looking at week 9's topic, which is let's look at our topic for today. Midnight topic, carbonate compounds, still talking about carbonate compounds. So we are looking at carbonate 4. So our learning objectives are: one, explain the preparation and properties of carbonate 4. So at the end of the class, you should be able to do that. Identify the soluble and insoluble carbonate 4. Explain the action of heat and acid on carbonate 4. State the uses of carbonate 4 and describe the test for carbonate 4. These are our learning objectives. So let's go to the topic proper. Carbonate 4 acid. Let's look at that first of all. It's formed when carbon 4 oxide dissolves in water. So when carbon 4 oxide is dissolved in water, you have carbonate 4 will be formed. Remember, now in this equation, carbon 4 oxide is called the acid anhydride. So it dissolves in water to give us carbonate 4. Carbonate 4 acid is a weak diabasic acid, meaning that it ionizes partially in solution to give us hydrogen ion and the CO3 radical, CO3 2 minus. So, and it's diabasic, producing 2 hydrogen ion. So that is what we mean by weak diabasic acid. We studied that in our previous classes. Then carbonate 4 acid can form 2 types of salts. Number one, the normal carbonate 4 salt and the acidic hydrogen carbonate 4 salts. These are the 2 types of acid it will form. So now carbonate 4, one of the major uses is that they are used in soft drinks, carbonated drinks, and sprinkling wine. Now these drinks are what happens is that the carbonate 4 acid is dissolved in these drinks, and then it produces, when it is dissolved in this drink, it will produce carbon 4 oxide, which help to give the drinks refreshing taste. I remember talking about that when we were talking about carbon 4 oxide, that they give refreshing drink to drink. So actually this carbon 4 oxide is produced when this carbon 4 carbonate 4 acid is dissolved in this drink. So it produces carbon 4 oxide, which gives those drinks um, the refreshing taste. So that is for carbonate 4 acid, one example of a carbonate 4. So let's look at carbonate 4 themselves. Carbonate 4, they are normal salts of carbonate 4 acid. They contain the carbonate 4 ion CO3 2 minus. Examples, we have sodium carbonate 4, you have sodium carbonate 4, you have calcium carbonate 4, then you have potassium carbonate 4, zinc carbonate 4, and so many other examples. They are right there in your note. So these substances that contain the ion CO3 2 minus is known as the carbonate 4. So they occur naturally as ores, e.g. you have calcite, dolomite, limestone, chalk, marble, and then you have magnesite. So these are examples of the natural ores of carbonate 4. So they occur naturally. You find them in abundance in as ores. So going on, let's look at the preparation of carbonate 4. Carbonate 4 can be prepared in several ways. For example, sodium, potassium, and ammonium carbonate 4 are prepared by bubbling carbon 4 oxide through a solution of the corresponding alkaline. Why are these 3 exempted from others? Because they are soluble in water. So they are prepared when they bubble them through carbon 4 oxide, bubble their alkaline through carbon dioxide. So you have the product there. For example, when sodium hydroxide and alkaline is bubbled through carbon dioxide, you have sodium chalcocarbonate 4. And then when you bubble calcium hydroxide in carbon dioxide, you have potassium chalcocarbonate 4. Then ammonium hydroxide bubbled through carbon dioxide, you have ammonium chalcocarbonate 4. I told you that these three chalcocarbonate 4 are soluble in water, so that's why they could be prepared by this method. Next one is sodium and potassium can be prepared by heating the corresponding hydrogen chalcocarbonate 4. Now, why is this possible? Because sodium and potassium chalcocarbonate 4 are not decomposed by heat. So when you heat their hydrogen chalcocarbonate 4, they'll produce those substances and you have water and carbon dioxide. Hope we are following that. So this is another method of preparing them. Then for the insoluble metallic chalcocarbonate 4, remember I told you that all other chalcocarbonate 4 are insoluble except sodium, potassium, and ammonium. And ammonium chalcocarbonate 4, they are soluble in water. So that's why others can be prepared by double decomposition. What happens in double decomposition is that a salt, maybe for example, you want to produce calcium chalcocarbonate 4, so you react it with a salt of calcium. For example, you have calcium chloride with sodium chalcocarbonate 4, and a double decomposition means that this CO3 will replace the chlorine ion in this calcium chloride to give you calcium chalcocarbonate 4, and then you have sodium chloride. So you have your calcium chalcocarbonate 4. Another example, you have silver chalconitrate 5 reacting with sodium chalcocarbonate. So this chalcocarbonate 4. So this calcium chalcocarbonate 4, this chalcocarbonate 4 ion will replace the chalconitrate 5 ion to give you silver chalcocarbonate 4, and then you have this other source. So these are methods used in preparing chalcocarbonate. Now, properties of chalcocarbonate 4. Now, all of them, I said that the short while again, are insoluble in water except those of sodium, potassium, and ammonia. And then when these soluble chalcocarbonate 4 hydrolyze, they form alkaline solution. For example, sodium chalcocarbonate 4 will hydrolyze to give you sodium hydroxide and chalcocarbonate 4 acid. Remember, chalcocarbonate 4 acid is a weak acid and sodium hydroxide is a strong alkaline, so it will become alkaline. That means it will turn red litmus blue in this solution. So that's why we say that it hydrolyzed to give us alkaline solution. The same thing with potassium hydroxide. So when you dissolve it in water, it will give you an alkaline solution because sodium hydroxide is a strong valence. So chalcocarbonate 4 acid is a weak is a weak acid. So going on, we look at with the exertion of sodium and potassium chalcocarbonate 4, all chalcocarbonate 4 decompose on heating. So remember in the first case, all chalcocarbonate 4 are insoluble except those of sodium, potassium, and ammonia. Now again, action of heat on them is that they all decompose on heating, but sodium and potassium chalcocarbonate 4 does not decompose on heating. For example, you have ammonium chalcocarbonate 4. When heated, will give you ammonia, water, and carbon dioxide. So they produce carbon dioxide when heated. Those which decompose on heating. So they produce carbon dioxide on heating. So another properties of chalcocarbonate 4 is that they react with dilute acid to form salt water and give off carbon dioxide. So for example, you have when zinc chalcocarbonate 4 is this react with hydrochloric acid, you have this product that carbon dioxide is giving off. Look at another example, silver reacts with this acid chalconitrate 5 acid, you have the product, and then you have carbon dioxide giving off at the end of the day. These properties are very important. Remember, we said the action of heat on them is that they all decompose on heat, but sodium and potassium triazocarbonate 4 will not decompose. But for the action of acid on them, that they will react with acid to give off carbon dioxide plus other products, which just water and then a salt. Like with zinc, you have zinc chloride reacting with hydrochloric acid. So uses of triazocarbonate 4. 1. Sodium triazocarbonate 4, known as soda ash or washing soda, and potassium triazocarbonate 4, called potash. They are used as washing powder for cleaning. They are used they are used for washing powder and are also used for cleaning. So that's one use. Sodium triazocarbonate 4 is used in the manufacture of glass, soap, and detergents, and also in the production of paper and pulps. Then calcium triazocarbonate 4 is used in the production of cement, chalk, and imported chemicals such as quicklime, which is calcium hydroxide. So these are the uses of triazocarbonate 4. So let's look at hydrogen triazocarbonate 4. Now, we just talked about triazocarbonate 4. Those are normal sort of the acid triazocarbonate 4 acid. So hydrogen triazocarbonate 4 are the acid sort of the acid triazocarbonate 4. So hydrogen triazocarbonate 4 are acid salt of triazocarbonate 4 acid. Hydrogen triazocarbonate 4 contain, now the ion that hydrogen triazocarbonate 4 contain is HCO3 minus, and they are formed when a metal or ammonium ion replaces only one of the two hydrogen in triazocarbonate 4 acid. Hope you get that. So examples, you have the sodium hydrogen triazocarbonate 4, potassium hydrogen triazocarbonate 4, then you have calcium hydrogen triazocarbonate 4, and so many other examples that are in your notes. So preparation of hydrogen triazocarbonate 4, they may be prepared by passing carbon dioxide through a solution of corresponding hydroxide or triazocarbonate 4. For example, you have this. Now, you have sodium hydroxide reacting with um, um, carbon 4 oxide to give you sodium hydrogen carbonate 4. Now, let's go back. So when we are talking about preparation of for example, look at, in this case, you have excess sodium hydroxide, that's excess of the alkaline reacting with carbon 4 oxide to give you sodium triazocarbonate 4. But in this other case, in the preparation of hydrogen, so you have limited supply of the hydroxide of the alkaline sodium hydroxide, so it reacts with carbon 4 oxide to give you sodium hydrogen triazocarbonate 4. Then also you can also get react it by passing carbon 4 oxide through the sodium triazocarbonate plus carbon 4 oxide and water, and then you have hydrogen triazocarbonate 4. If you balance this equation, you have 2 here. Hope we get that. So you have 2 there. So that will give you the product. Good. So these are the product of how hydrogen triazocarbonate 4 can be prepared by passing limited amount of the alkaline over bubbling it through carbon 4 oxide, or triazocarbonate 4 oxide through carbon 4 oxide to give you hydrogen triazocarbonate 4. So properties of hydrogen triazocarbonate 4 include: 1. All triazocarbonate 4 are soluble in water. Now, remember, for triazocarbonate 4 themselves, they are all insoluble in water except those of sodium, potassium, and ammonium. But all hydrogen triazocarbonate 4 are insoluble in water. Now, calcium hydrogen triazocarbonate 4 is responsible for hardness of water. What is hardness of water? Because of the presence of this dissolved salt in water, it will not lather with soap. That means when you are using it to wash, it will not form lather with soap. So it will make washing of clothes difficult. So that is due to the presence of calcium hydrogen triazocarbonate 4. So moving on now, we'll have please excuse me for a moment. So back to what I was saying, we have those. So we have of the hydrogen carbonate 4, who is responsible for hardness. Calcium hydrogen is responsible for hardness of water, and then we said that of the hydrogen carbonate 4, only those of ammonium, sodium, and potassium can be isolated as solid. That means because they are readily soluble in water, you can't find them as solid substances. So that's another property they have. Then all hydrogen carbonate 4 decompose readily on heating to yield the corresponding carbonate 4 water and carbon 4 oxide. Remember that when we're talking about carbonate 4, they are they are decomposed by heating to give off carbon 4 oxide. But sodium and potassium cannot be decomposed by heating. But in this case, all hydrogen carbonate 4 are decomposed by heating. They are affected by heat, including the sodium and potassium. They are all decomposed by heating. So we have the product there. Then, like the carbonate 4, hydrogen carbonate 4 reacts with dilute acid to form salt water and give off carbon 4 oxide. So you have all these equations. For example, you have sodium hydrogen carbonate 4 reacts with this acid to give you this salt water and give off carbon 4 oxide. The same thing with hydrogen carbonate 4. And calcium hydrogen carbonate 4 reacting with an acid give you salt water and carbon 4 oxide. Then uses of hydrogen carbonate 4. Sodium, for example, sodium hydrogen carbonate 4 is used in baking powder to discharge carbon 4 oxide, which helps the dough to rise. Remember, we said that carbon 4 oxide helps dough to rise. So it's due to the presence of this sodium hydrogen carbon 4 that will react with the mixture of the dough. With those mixtures, it will produce carbon 4 oxide, which helps dough to rise. Then sodium hydrogen carbonate 4 is also employed in medicine to relieve indigestion. For example, in Andrew liver salt, you have sodium hydrogen carbonate 4, which helps to relieve indigestion. Okay, so going on, let's look at the test for CO3 2- and HCO3-. Remember, these are carbonate 4 ion and hydrogen carbonate 4 ion. When you add dilute hydrochloric acid to a solid or a solution of metallic carbonate 4 or hydrogen carbonate or hydrogen carbonate 4, the result is a rapid effervescence, that is production of the gases. Now, a colorless, odorless gas which turn moist blue litmus paper pink and lime water milky is liberated. Remember when we talked about carbon 4, I said that the test is that it turns moist blue litmus paper pink and then lime water becomes milky when it is labeled. So carbon 4 oxide is what is produced because those substances, when we talked about their reaction just now, they react with acid to give off carbon 4 oxide. So let's take a look at this image. You see, so that carbon 4 oxide, when you bubble it through lime water, it will give you a precipitate, so it will turn it milky. So these are the tests for for carbonate 4 and hydrogen carbonate 4. They will produce carbon 4 oxide when reacted with HCl, that's hydrochloric acid. So they will give they will turn moist blue litmus paper pink and turn lime water milky because carbon 4 oxide is produced. So this is where we are ending the class for today. Go to the school website and you see the note for this week, or it's for week 9, right there on the school website. and you can refer to new school chemistry, then exam focused chemistry, and then essential chemistry. These are where what will help you to understand the topic better. Please, in case of any question, you can send me a chat on the school website, or you can as well send me a WhatsApp message, and I will answer you as soon as I get your question. Thank you very much for listening. Keep staying safe and God bless you. So until I come your way next time, I am Miss Adana. God bless you.